My name's Alan Miller. I'm the leader of the Aspire Linlithgow fundraising team, and it's my huge pleasure to welcome you all to St Michael's Church this afternoon. And a particular welcome to the third-year physics students from Linlithgow Academy, and also a request to switch your phones off, please, guys. Now, we're here this afternoon because of two remarkable people. One of them is Charles Wyville Thomson, chief scientist on the HMS Challenger expedition in the 1870s and still credited as the founder of the science of oceanography. You won't hear from him today because he died in 1882. But he still makes his presence felt here. He's buried in the kirkyard, and more importantly, the great east window at the east end of the church celebrates his life and his work and the wonders of the natural world. So, physics pupils, you'll notice we still have a few plain windows that could be decorated. Just think a few decades ahead to when you become eminent scientists in some new field and somebody pays to decorate one of these windows in recognition of your great achievements. Have a think about that. However, it's the other remarkable person who has brought you here today. Oceanographer, astronaut, global pioneer for women in science, please give a warm Linlithgow welcome to Dr. Kathy Sullivan.
Let me share a few tales with you about my path. I don't have any windows after me, thank you very much, but my path to the adventures that Alan mentioned. It does not start anywhere you might predict would have ended up the way it's done, so hopefully it's a bit of an interesting story, and for those of you young people who maybe are still kind of figuring out what you're interested in or what you might be good at, or what you'd like to do with your life and your work. When I was your age, I was quite certain what I was going to do because I have a flair, a knack for foreign languages. I did not have a particular job in mind, but I was aiming for a life or career where people would buy me airplane tickets so I could go live in and explore some of the many places I had read about in National Geographic and the various books I'd read growing up. So my career objective was someone has to buy me airplane tickets. And I was absolutely dead set. My language skill is what's going to get me there. That got me as far as university, but it all changed from university onward. So maybe we can go to the slides. I don't have too many slides to throw at you. And when we're done, I'd love to hear your questions. So my main motive in sharing these slides is actually to prompt your questions. Fair warning to everyone who's seated 1, 2, 3, fifth pew and beyond. I give preference to students over oldsters like me, but we'll get to as many as we can. Anyway, these are all pictures of me when I was 5-ish, 6-ish, 4, 5, 6 years old. In the middle, I was an avid reader. I was probably more like 3 there. Started reading at a very young age and quickly realized this was not just the avenue to stories that might amuse me. It was a first avenue to explore. I loved books of other young people and older people who were doing the kinds of things that I imagined. None of the characters in those books, as a rule, were female. But in our family, the ethos was not, well, you've read about a man that's done it, but girls don't do that. The ethos was, well, yes, people have lives like that. There's no reason you can't have a life like that. So you can take inspiration from anybody. They don't have to look like you in order to teach you a lesson or give you some inspiration. And as you see on the left and the right, I was also pretty adventurous from a very early age, and my mother, who's reaching up to catch me on the right, was not a very adventurous woman, but she did not put any of that on me, so she actually encouraged my adventurousness, which I think she loved when I was 3 years old, jumping into her arms. When I was older and telling her I was going off into the mountains or to a foreign country and on my own and be gone and incommunicado for 6 weeks, she was less and less thrilled about it. But by that time, it was a done deal. So that's the motivations, again, deep motivations, but very, frankly, vague. If we can go to the next one. So that led me to college, as I said, where I was forced to take 3 science classes, despite intending to major in languages. And I thought that was a really terrible idea, and I argued against it vehemently, and I lost all the arguments. And so I ended up in 2 classes about oceanographic sciences. And the professors that were teaching them and the people that we were reading about, they were living that kind of life I was looking for. Inquisitive, adventurous, going interesting places, and actually digging in to learn, what is this place like? What are the people like? What is the landscape like? The book on the right, Great Waters, is more memoir than textbook, but it was the only book we used for our first year marine biology class. And it also has a connection to this neck of the woods, because that's the Royal Research Ship Discovery on the left. She's now alongside as a museum ship in Dundee. And the young scientist aboard who wrote this memoir was Alistair Clark, later Sir Alistair Clark. And it was a fabulous story. It was a coming-of-age tale of him as a young man going off to the far reaches of the Antarctic. It was a travelogue of all the places they stopped. And it was a treatise, a textbook, a primer on how do you do research at sea. I couldn't get enough of it. So after the second similar course, a term later, I abandoned my language major, switched to a science major, and finished with a degree in earth sciences, and acceptance at Dalhousie University in Nova Scotia to do my PhD, doing the same kind of science Alistair Hardy had done, but in the Atlantic Ocean. So next one, off I go to graduate school after being inspired by this gentleman and his tale. And I'm just finishing my PhD. I mapped a piece of the seafloor off Canada, first person to make a detailed map. The cool thing is that means you get to name the mountains that are on the bottom of the ocean. So I got to name seamounts in the North Atlantic. And just as I'm coming towards the end of my dissertation, NASA puts the advertisements out recruiting for explorers who will explore on this new thing they're building, a space shuttle. And this was now 1976, 1977. Every astronaut in the United States beforehand had been a male military test pilot. Once you have something like the space shuttle, you need those super skilled test pilots to fly it for launch and entry. But then it turns into a research ship once it's on orbit. And you need scientists and engineers to prepare all the equipment, to install it in the ship, to take it up and then conduct the experiments, deploy the satellite, do all the business that brought you to getting on orbit in the first place. Called that group of people mission specialists. And the advertisement for both the pilots and the mission specialists just said, anyone who has these credentials and some degree of practical experience to show that you're skilled at applying your credentials, which meant anybody could apply. They got close to 10,000 applications. They winnowed that down to 200 to invite down to Houston for interview and physical exams and psychological screening and all of that. And as you saw in the left-hand image on that slide, out of those 200, they chose 35 and we came aboard in 1978. We got to create and design that crest. You all have school crests. It was the crest for our group of astronauts that we got to design. And we had some distinctly not male and not Anglo people in the class. On the right, you see the 6 women that were in our first group. I'm the one closest to the spacesuit on the left. And the name you're more likely to recognize is the name of the woman on the far right. That's Sally Ride. So there we go. We're now rookie astronauts. We have not actually done anything real yet. We've just gotten in the door, been given our blue flight suit, and put in front of the cameras. But it was a fun start to what we knew would be a grand adventure. So the next slide, this is the craft that I flew on 3 times. You see the 3 crests on the bottom that, again, we designed, just the people on the crew. A space shuttle had those big clamshell doors closed for takeoff and for landing. But once you were on orbit, you open the big cargo bay doors. And you can see the cargo that that Discovery is carrying on this trip. There's what looks like a tin can back near the tail. That's a very sophisticated laboratory module. And it's connected to the cabin of the space shuttle with a tunnel. So some of the crew could be in that laboratory at the back doing up to 60 different kinds of experiments. And a couple of crew would be in the cabin on the left towards the nose, managing the ship itself, keeping it in the right position, looking after the engines and computers and so forth. So that's the shuttle it only goes to Earth orbit. It didn't have enough propellant to leave Earth's orbit and say go to the moon. And it could stay aloft for up towards maybe about 2 weeks before it needed to come back home. So we'll dive inside the space shuttle now and just get a couple of peeks of what's it like to live and work in zero gravity, whether in this shuttle or the station. This is one thing you get to do. That's me on the left, actually, and my partner Dave on the right, outside to do a spacewalk. Our main objective was what you're seeing us do now at the very back of the cargo bay. It was an engineering test to prove that we could refuel satellites while they were on orbit. Now that's me floating a bit to the upper right. There's still been under 700 people ever fly in space. And of those 700, there's been something under 200 that have done a spacewalk. So it's a pretty cool privilege to get to fly in space, and it's a very coveted thing to get assigned, to get tapped to do a spacewalk on top of that. So let's go now inside the cabin itself. You get a sense of what's it like to move around. So your feet are kind of useless. You swim, basically. You pull yourself hand over hand. You saw the upper deck. Now you're in the lower deck. This is my first crew. We had 7 people aboard, which is pretty crowded for a small space. And so we decided, just as a joke, the way you make this work is you just keep everybody moving all the time, so you don't feel the crowd. The combined area inside the space shuttle cabin, by the way, if I take this platform that I'm on, roughly split it here in the middle, and stack the one on the other. And it's 2 panels wide, maybe add a third panel. So that's the total area you're living and working in. This was a 10-day mission with 7 people in that little space. The lower deck that you saw is where we would sleep, make our food, all our equipment was stored, our clothing was stored, some small experiments were stored there. And the upper deck is where you would operate if you were deploying a satellite, using the robotic arm, commanding the spaceship. So it was a pretty fun place to live and work. But again, as you can see, you're just kind of swimming anywhere you want. So this is St. Michael's is a great space to imagine yourself to be in with no gravity. We could have 3 times the audience in here, because I could have a whole other bunch right around these column lights, and a whole other bunch up above. I maybe could even get a fourth one in if we really wanted to, because everybody could just float anywhere they would like to float. This would be a wonderful fun space to turn into a zero-gravity jungle gym. So let's go on from there. You had some glimpses of the shuttle and our space operations. Playing around in zero gravity is the favorite thing of all astronauts. It's also very fun to play with your food, by the way. Your water will turn into little balls and drift through the cabin. Your goldfish crackers will actually form a school and just drift through the air. The second fun thing is just look out the window. And so glimpses like this of the Sinai Peninsula, the dark thing on the left that looks sort of like a funky flower on a long stalk. That's the Nile River flowing north to the Nile Delta into the Mediterranean Sea. The two blue arms that you see near the bottom of the slide, the one on the left is the Gulf of Sinai. If you follow up to the very top of that, you'll see a little sliver of dark. That's the Suez Canal. And the one on the right is the Gulf of Aqaba. And it's a commonplace to say astronauts come home feeling very idealistic from orbit, in part because you can't see global international boundaries disappear. You kind of realize it's one Earth, and we're all crew members on this little spaceship Earth, and many of the divisions we get into such angst about here on the ground kind of fade away. But if you look really carefully on this slide, you can actually see the 1973 treaty boundary between the Arabs and the Israelis. Look at the lower right-hand corner of the Mediterranean blue, and you'll see sort of a dark surface color coming down along the Israeli shore, and then very abruptly, it's just tan sand. And that boundary between the darker and the tan sand is actually a political boundary. And slightly different land use practices on the one side or the other create a line that your brain will see and recognize. Even between the United States and Canada, out in the Great Prairies, there's no physical security border there, but your eye will recognize the difference between the land use pattern in the United States, which is very perfect squares, and on the Canadian side, which is just a different pattern of ownership on the ground. It's really kind of fascinating. So that's a daytime view. It's equally glorious to look at the Earth when you're on the back side of the Earth, away from the sun, and you're flying over areas in the middle of the night. So the next slide is what that can be like. Again, you're over the Mediterranean, just south of Corsica, Sardinia. You're looking to the north. You're seeing the leg of Italy come up from the right. You're seeing the Po River Valley, where the greatest density of lights are. That's the Po River Valley. And just beyond that, to the upper left, you see sort of a white arc, a whitish arc. That's the snow-covered crest of the Alps. Enough moonlight on this night that you're really seeing the snow lit up very brilliantly. But these are great images to give people geography tests on. So just look at patterns of lights and can you tell me where you are? Because again, the geometric patterns of settlement are quite different from continent to continent. So if you floated up to the window, middle of the night, you've not looked at on a map to see where you are, and you looked out the window, within about a week you'd be able to tell what continent you're over because of the shape of the patterns of the light on the ground. So next one then. So we'll shift gears. So started in the oceans, become an astronaut, never gave up being interested and fascinated by the oceans. And in fact, between my space career and this moment in 2020, I went back to sort of the ocean and earth science roots, and I was chief scientist of an agency in our government called NOAA, the National Oceanic and Atmospheric Administration. That's the parent organization to our National Weather Service, to a major weather satellite operation, to a fleet of ships and airplanes, to a big research arm, and the management of ocean fisheries for the United States, all under that umbrella. And what I loved about NOAA is it does not exist just to collect scientific data and publish papers. It collects scientific data, and it harvests scientific data from everywhere else in the United States and on the planet, with the aim of understanding what questions or challenges people in the real world are facing. And so, some days those are daily and trivial ones, like I've got to drive across country, and is it going to be snowy or rainy or just an easy drive on a sunny day? Well, that's how we use a weather forecast. But maybe I'm a shipper and I've got a cargo going across the ocean. I'd like to know if there's a big storm I need to steer away from and avoid. Weather forecast. But it can go on from there to a farmer with a large agricultural plot wanting to not put fertilizer down the very day before it rains, so that all the fertilizer just runs off the ground into the river, plus he has to buy another load of fertilizer. So practically, information about our Earth, how it works and what it's doing, that's tailored to a decision in the real world. It's a fun brokerage. And it was my pathway to sort of shift back to applying the information and knowledge about the Earth, applying the space perspective that we have from satellites, and getting back to my ocean roots. So delightfully, in 2020, I got an invitation out of the blue to go dive to the Challenger Deep. And we'll go to the next slide and get a little orientated about, well, where is this? And what does the deep part mean? So pretty typical map on the right. You can see Japan, China, the Philippines, and you can see the black words indicate where the Marianas Trench is, an arc-shaped feature that's very deep in the ocean. And the red arrow coming out from there points to the other map, which is a weird map, a very weird map. So this is flatten the Earth, centered on Antarctica. Color all of the land masses black. Then drain the ocean, drain 20,000 feet of water out of the ocean. So the brown is sort of, well, that's the muddy bottom that you would be seeing if you drained away 20,000 feet of water. But you notice there are little patches of blue still left. Many of them are an arc shape, not all of them, but many have this arc shape. Those are the areas in the ocean that are deeper than 20,000 feet. And they look like very small little slivers and snippets compared to the scale of the ocean basin. But they're massively deep. So a huge proportion of the volume of the ocean is in those little slivers. And the left-hand end of that red arrow points to where the Challenger Deep is in that context. So that's where you are geographically, east and west, north and south. Where are you top to bottom? That's what we have in the next slide. So top to bottom, Marianas Trench is that blue triangle pointing downward on the left. It's, in round numbers, 36,000 feet deep, 11 kilometers deep. And just to provide a sense of proportion, the white triangles on the right are first the Matterhorn, and then Mount Everest, and the little itty-bitty triangle is the famous Burj Khalifa Hotel in Dubai. If you could sink Mount Everest into the bottom of the Marianas Trench, the top of Mount Everest would be 1 mile underwater. That's the punchline there. And then if you see the little figure of a jet airliner right up at the top of the black bit, if you go to the bottom of the Marianas Trench, you are further underwater than commercial airliners fly above it when they're flying across the Atlantic or across the United States. So just to give you a sense of scale. So the next slide, off we went, June of 2020. You'll remember COVID was in its heyday, but we managed to sneak through all of those health provisions successfully and get to Guam and get on the ship and spend a day and a half sailing down towards the Marianas Trench. This is a look at the inside of the craft that I was going to go down in with Victor Vescova. That's the gentleman on the right. So you're looking down the hatch that we had to climb down through in order to get inside the submersible. You can tell it's a bit cozy. It's not as bad as a budget airline short-haul jet. It's a little roomier than that. Certainly more leg room. But there's no one sitting in front of you that's going to recline their seat into your face. But by the same token, your seat doesn't recline either. So that's it. You can see lots of instrument panels behind us, and there were more, of course, in front of us. So 2 people. On the left, you see the circular element of the submersible in the center. That's the business part. That's the part you care about the most. That's a sphere, a 5-foot diameter sphere made of solid titanium. The thickness of the walls is about 3.5 inches. And the reason you care about that is at the bottom of the Marianas Trench, the pressure outside is 1,100 atmospheres, 1,100 times what we experience here, which translates to, round numbers, 16,000 pounds per square inch on every square inch of the outside of that sphere. Squishy little bodies like ours can't take that. So the titanium sphere keeps all of that outside, and inside you'd be just like you are now. You could be dressed just as you are now. You get a little cold because the water temperature is cold, but same pressure, no bends, none of that. Just sit very still for a long day. Our dive plan was this submersible required 4 hours to get to the bottom. We would then plan to spend 4 hours doing the scientific work and another 4 hours coming back up. So a long day in a small-ish seat that doesn't recline, but actually pretty comfortable. So there we are. That's what we were hopping into. And the next slide you'll see, just as we've been put in the water and are beginning our descent in the lovely clear Pacific water, all of the daylight is gone by about 1,000 feet, and then you're just descending through the dark. You can, well, hard to see on this image actually, but the whole front of that submersible is just blistering with lights, high power lights, which we did not turn on until we got near the bottom, because the lights would draw down your battery. That's the same battery that lets you maneuver on the bottom. So you have to decide, where am I going to spend my battery? We're also descending about 100 feet a minute, so twice the height of the church in every minute. That's not crazy fast, but if there's any life in the water that you would like to see, it's just going to go by your window in the street. So there's no point turning the lights on. So the next slide, I think we're on the bottom. Yep, it's me on the bottom. I get cold easily, so I had a ski cap with me. I had my NASA flight jacket on. I had some down mountaineering boots to put on my feet. The water temperature outside is 32 degrees Fahrenheit, so it's freezing temperature. It won't freeze because of both the pressure and the salt, but it's the temperature of ice water, and the metal of the sphere will pick that temperature up, and the inside will get colder and colder. So you are kind of sitting in a refrigerator at this point, and you've got another 8 hours to go. And the next slide, you're going to be on the bottom of the Marianas Trench. So you're now flying about this far off the bottom in the center part of the trench. So it's relatively flat, covered with sediment and silt. All these little knobby things that you're seeing, though, they're creatures. They're invertebrates, bristleworms, sea cucumbers. We know these creatures from much shallower waters as well. These are like the super deep cousins of the ones that we're more familiar with as scuba divers. So we maneuvered along for a while. That's about all the life we saw. We were doing more physics and geology than biology on these dives, so we didn't stop to look carefully at the critters. But in the next clip, and we could start the next clip now, I'm going to give you a glimpse of one of the little critters you might find down here. So the orange and bluish stuff on the right, that's an instrument package that we put on the bottom before we launched the submersible. This has a navigation beacon, and it had its own instrumentation and sampling gear. And when this one landed, it clearly landed on or near one of these little worms who was not very happy about having something plop down on its head. And you're starting to see that little white dot. That's the, well, at least annoyed worm that's just trying to get out of the way of this thing. So notice it's moving by its whole body. It's got fine little hairs it uses to filter feed. And as it went by, did you see something yellow in it on the inside of it? So most creatures down here are either albino, they're just white, or like this little guy, they're transparent. And the orange bit you were seeing was the stomach and digestive tract, which is commonly the way these guys are built. It doesn't make any biological sense to spend energy making pigments at these depths, pigments that we would see as color with our eyes, because none of our wavelength of light gets down to that depth. So albino and transparent are smart things to do. Next slide. Again, you're 160 miles from it, the last little tiny bit of nearby island. You're 36,000 feet down, and yes, there's junk on the bottom. This is fiber optic cable that's been released from different scientific expeditions. Another dive saw a Ziploc baggie floating along, like could have looked like a sea cucumber, but it was a baggie. And a soda can has been seen down there. So it does not matter how far away from land or deep in the ocean you go, or anywhere else you go on land. The lesson I would leave with you from this is there is no place and no living thing on this planet at all that is not interconnected to every other place and every other living thing, period. We know some of those connections. We've mapped them and studied them. We certainly don't know all of them. They may be very subtle. That doesn't mean they're not there. So the scale and richness of interconnection across all the ecosystems of the planet and all the living things of this planet it's a fundamental reality. I think it's very easy for us to not pay attention to as we wander about here on land. The next one. So I'll pick up where Alan's introduction touched on, and it really is one of the reasons it means so very much to me to have the invitation to be here for this week. My interest that really sparked my career started with the oceans, started with voyages of exploration, more discovery in my case than Challenger, but that came full circle in 1984 when I flew on the Space Shuttle Challenger, named for HMS Challenger. All of NASA's space shuttles were named for renowned research vessels, which I quite loved as an oceanographer. If we go to the next one, it's meant a lot to me all this time that I flew on a vessel that was the namesake for that vessel. That's HMS Challenger in an artist's rendering. 1870 to 1984, 110 years later, her namesake, Challenger's namesake, is flying in space. And then another bit of a fast forward to 1986 and onward in the next one. You recall very tragically the Space Shuttle Challenger exploded during a liftoff on a launch in January of 1986, killing all 7 people aboard. 4 of them were my classmates. Another one, the 5th one, was a very good friend, 1 class junior to us. And the families, the grieving families left behind, they knew streets would be named after the deceased crew members and schools and lots of inanimate things. The purpose of that, a big purpose of that Challenger mission, was to take a teacher to orbit and teach some lessons from space. The whole crew really got behind that effort and really committed to that effort. And the wife of the commander was a teacher herself. So as they processed the great loss they had experienced, where they quickly settled to was, we want there to be something alive that keeps the spirit and intention of the educational mission alive. And so June Scobie, the commander's widow, was the spearhead for coming up with some kind of educational institution that would help keep that dream alive. I had the great honor and privilege of working with June to figure out off of a blank sheet of paper, well, what would that be? What could that be? And it became this thing you saw on the left, the Challenger Center for Space Science Education, which, unlike, you could think of it as a science museum. It's a science museum that doesn't actually have a building. Instead, it works with schools or other museums and creates a simulation, a mock-up of a mission control and a spacecraft at that school, at that site. And you see on the right, students of all sorts of ages, and even adult work groups looking for some team building activity. They come to Challenger Centers, they've each been schooled up. Everyone has a role on a mission. You're the communication officer, you're the life science officer, you're the spacecraft commander. Another cohort is in the mission control as the flight director. And they are set problems. They conduct a mission, a simulated mission, with problems injected that they have to figure out how to resolve. So it gets to some scientific and technical knowledge, it gets to collaboration, it gets to communication. It's been a tremendous success. I think it's currently operating at 35 different locations in and beyond the United States. It's served millions of students and adults in the years since it was founded. And I've been delighted to have a role in having started that, so it's a second touch of Challenger for me. And then I think we've got one more, which is this right here. So when Alan and company asked if I'd come over and be part of this effort and some fundraising to help support the renovation of the window, those are the beads on the string that created so much meaning for me. From the research heritage to my flight on the Challenger, to the Challenger Center, and then the chance to see this spectacular window. I know the name Wyville-Thomson because there's a major ridge, a major topographic feature on the bottom of the Atlantic Ocean. It's known as the Wyville-Thomson Ridge. I learned about that when I was 17 years old, long before I figured out Charlie and Challenger. And as Alan pointed out, the panels on the bottom there, the four on the bottom, are dedicated to HMS Challenger in her expeditions. You can kind of look at the creatures that are shown in the stained glass window, and there's a pink dolphin, which tells me they explored the Amazon. There's a red lobster, which you might think means they showed a cooked lobster, but there's apparently actually a pink lobster in New Zealand that's pink before it's cooked. All sorts of wonderful representations of the sea life. And as Alan mentioned, his tombstone's just outside the back there. So you have such a fabulous gem here in this church and in this window and in the history of Charles Wyville-Thomson leading the Challenger expedition. So to get to be here, to get to see this, which I did not know about, another wonderful bead on my string, and then to get to spend some time at the university over the next couple days looking at some of the archives and the logs, the original materials that Challenger brought back. Just couldn't have had, if you'd wanted to make a better offer, you couldn't have asked me to swap those for some big fee. I was happy to give away any kind of fee for the experiences that Alan and Ian and his team here have set up. So that's my story. That's why you have a Southern California linguist turned astronaut standing in front of you, and why she's very grateful to be here. And I've now talked plenty much, and it's your turn. So I hope you've got some questions thought up for me.
Well, thank you so much, Kathy. And we hadn't actually talked about your fee, so I'm glad you said what you said. That's great. And I see Jane Brown at the back with a roving microphone. So we're very happy to take questions. Can I suggest you ask questions about anything at all related to what Kathy has said, but let's avoid including 2 words in your questions. One of those words is president, and the other one you can probably work out for yourselves. So let's start at the front. Who has a question for Kathy?
And I could say lots about both those words, but it'd be nowhere near as fun. All right, counting on Academy here, come on.
Were there any similarities between
No, you got very echoey in here, so you speak loud and a bit slow.
Were there any similarities between the Mariana Trench and space?
I'm still having trouble hearing it. Oh, thank you. Yes. They're actually, that's me, not you, not to worry, or it's the church. There are some really intriguing similarities between exploring sea and space. Mainly the technical ones, and I'm fascinated still by both of them. You can't go to either place without engineering, right? You're going to die in space because there's nothing to breathe. You're going to die in the deep sea because you get squished and or drowned. So the engineering and technology that lets you keep the bad stuff out, make sure the inside, where you want to be, is still in that narrow range of pressure and temperature that we could tolerate, that it can recirculate or scrub the air. For a spaceship or a space station where you'll be days or weeks or months, you have to think about providing nutrition, human waste, garbage. How are you going to do all of that on a 12-hour submersible day? That's a tiny little nothing. But it's pretty magical still to me to be able to be in a little tiny sphere dressed like this, eating my sandwich, looking through a porthole 34,000 feet underwater and knowing it seems completely obviously natural to be where I am. I understand how this all works, and I know I would die out there. And it's a kind of magic to be able to create those engineering solutions to do that. So some of the technology is quite similar, even like scrubbing the air underwater uses some of the same chemicals that we would use on the spaceship. But the big difference is, if you go from here to Earth orbit, you have to deal with a pressure difference of 1 atmosphere. That's 14.7 pounds per square inch. If you go from here down in the ocean, every 10 meters, every 33 feet, the pressure is raised by 1 atmosphere. So it's much harder to manage the pressure going deep in the ocean than it is in a spacecraft. One right there too.
Was the food any good?
Was the food any good? It was something between decent and good. So my shuttle flights were 5, 7, 10 days long. So, you can go camping and live on slop for 10 days if it's a good enough camping trip. So it was good. It was all rehydrated or packaged like you would for camping. We all had favorites. Believe it or not, rehydrated shrimp cocktail, which looked absolutely bizarre when it was dehydrated in the packet. You go, never in a million years. It actually rehydrated very, very well. And what was even better is you have these nice little shrimps that you could just sort of set spinning around the cap. So they were great. Orange mango was always the favorite drink, so people would fight over that. And M&Ms and goldfish crackers, because NASA would repackage those into like serving-size packets. But it was still fun to snip the top off. You're holding your bag of M&Ms, and we would do this routinely. You hold the bag of M&Ms, you pull the bag away. The M&Ms are right where they were. You pulled the bag. Some of them probably jostled against the edge of the bag as you pulled it away, and they're a bit wobbly, but you have a cloud of M&Ms or a school of goldfish. And you can just gulp them out of the air like the fish in your goldfish bowl would do. If your crewmate across the way wants one, they would actually say, "Send me an M&M," and you tap it, and it would drift over, and then they would just grab it out of the air. So it was, that was very fun. It's even more fun making a sandwich in zero gravity, because you can't put anything down. So, you might take out your tortilla and just leave it right there while you open the peanut butter jar. And just leave the peanut butter jar right there. There might be a little tab of Velcro on the lid, so you could Velcro it to a wall. And then, you take your knife and you get some peanut butter, leave the peanut butter there, put it on the tortilla, leave the tortilla. Yeah, that's everybody assembles a tortilla sandwich at least once, just for the fun of saying, "I think I'll just leave that right there," and it just stays there.
Did it have any physical effects on your body, going up to space into the bottom of the ocean?
Were there physical effects? Yes, if you spend an extended amount of time in zero gravity, a number of things happen. The most important one is it's the gravity signal is your body that needs calcium to keep the bones strong, so our skeleton can hold us up against the force of gravity. Well, and while we're standing here, while you're sitting there, your body is actually dozens at least of microfractures are happening in your skeleton as you sit there. It's constantly slightly fracturing and repairing itself continually. The repairing mechanism happens more slowly than the decay mechanism in zero gravity for reasons that are not completely understood. So what that means is you'll be starting to develop a version of osteoporosis with long time in zero gravity, no matter how old you are. So it's just that change in the reaction times. So you could end up coming home after a very long space flight with bones that are much more brittle, much more prone to fracture, a simple little bump or fall that you would just roll right back up from now. Might be a fracture after that. That's one of the key ones to worry about. There are also, we're seeing in the space station crews some kind of interesting shift in their optical nerve and the pressure in their eye. The calcium will tend to reverse itself naturally when you come home over a long time. The ocular stuff, the eye stuff, is not reversing in some people. So those are some of the points that are still being researched.
A question applicable to myself and many men. Is there still a maximum height restriction of 6 feet for the height of an astronaut?
There was a height restriction in the space shuttle. I think it was 6 feet plus some inches, because it was more like an airline cabin. The SpaceX Dragon capsules and the Russian capsules also have a height restriction. I don't know what they are for the Russian capsule, but the key problem in the Russian capsule is the way the seat is shaped for launch and landing. You're on your back, but your knees are drawn up quite close to your body, and so if the length of your upper and lower leg get out of proportion, you can't tuck your knees up enough. But I don't honestly know what that number is for Soyuz. The Dragon seat is not as demanding, so I think there's a pretty wide latitude on height with Dragon. We've got one here.
Do you still keep in touch with your colleagues?
Sorry, it's very...
Do you still keep in touch with your colleagues?
Oh, do I still keep in touch with my colleagues? I do with some. There were about 100 astronauts in the office when I was there, and we all have gone separate ways in a lot of respects. My partner on the spacewalk, who you saw in that clip, he and I always do, at least on the anniversary of that day, send a little email back and forth, remember where we were 100 years ago today. And the astronaut office puts on a big reunion party about every other year for those who can make the time in their work schedule and get back there and get some briefings, get some updates. You know, those of us that are sort of the alumni association, we're often asked to give talks. We're often contacted by the media to get some added perspective on things that are happening within NASA. So it's, you know, it's helpful to be able to stay current with what's going on in the current program, what are the plans, and to meet some of the current astronauts and just get their perspective. They are doing, today's astronaut corps is doing things very different than what I did. Their pattern of training and their cycle for flying and not flying is completely different than in the shuttle era. So it's pretty interesting to talk with them about how is that being managed now and how does it affect your thinking about, you know, your personal plans and your career plans. For us, I think if you got in the program, it was sort of sprint until either NASA says they're not going to fly you anymore or you've decided you're done flying and want to go on and do other things. And it's a very different tempo for the people in the Corps today.
What's been your scariest moment?
What's been the scariest moment? I honestly never had, like, you know, cold fear, certainly not, oh my God, we're going to die fear. Every astronaut will tell you that the fundamental thing they're scared about is screwing up. So famously, what's known as the astronaut's prayer is, please God, don't let me screw up, which is partly about I'm responsible for getting some things done towards the success of the mission, and I want to do my bit, and I want to be doing it well. And it's a little bit the embarrassment and endless teasing you know you'll get if you do muff something up. So everyone feels a bit of that. But we had no real meaningfully bad failures on any of my flights. We had one antenna that a motor short-circuited, and so we had to dig into the electronics and jury rig around that. So we had interesting problems to solve, but none that really had you thinking, oh my gosh, this is really very, very hairy. The subdive was the same. We were, I think, around 10,000 feet down, and there was an electrical alarm, something in one of the circuits. But all the electrics can fail completely in a submersible, and you're still fine. You're just dark, and you can't talk to the surface, but you're safe inside the sphere. And in fact, that submarine, there's about a 400-pound weight attached to the bottom of the sub that's what's making you heavy enough to descend. And it's attached to the sub with an electromagnet. So if all of your electrics fail, that electromagnet quits being a magnet, and that bit of metal drops away, and you'll be automatically on your way back to the surface. So that, again, that's an interesting problem to solve. Like we were only 10,000 feet or so down, and so I'm thinking, well, this could be the start of a set of events that mean maybe we won't get to the bottom, but well, then we'll see what happens. So we made it, and an hour and a half on the bottom is when the magnet quit, and we were on our way back up. So there's no override. You don't get to second guess this. The magnet makes the decision, and it's done.
What was your most exciting moment? What was your most exciting moment?
Oh, the most exciting moment. Every launch is very exciting. I mean, you are riding a bomb that has been designed and trained to be a rocket instead, but it's very dramatic, energetic. You're sort of embedded in a giant ball of energy, and it's going that way very fast. The very first time you look out a window and see the Earth from orbit will absolutely take your breath away. I've never met any astronaut that says any differently. I mean, it's just stunningly gorgeous. It doesn't ever get less gorgeous, but the very first time you see it as any first experience, has a sort of extra shock and surprise value to it.
I'd like to hear your answers. The question is this: if you spend and Kathy will elaborate once we've heard your suggestions. If you spend 24 hours in orbit, whether it's on Space Shuttle or the space station, in 24 hours, how many times would the sun rise and sun set? Somebody want to shout out a number?
Well, how many times does it rise or set in 24 hours here? One sunrise, one sunset.
Okay,
right?
I heard somebody say 16. Is that correct, Kathy? In 24?
Yes, it is. So you go around the planet in an hour and a half. If you guys are the sun, and this is the Earth, this bit is daylight, that bit's in the dark. You go through that hour and a half. So the sun rises here, and 45 minutes later it sets. 45 minutes after that it rises again, and that will happen, 1 hour and a half times 2 is 3, times 8 is 24, so 16 times. Any other trick question is...
We have time for two more questions.
Okay.
Right
here.
One here and then one at the front. So here first, thanks.
First of all, thank you for being a pioneer for humanity, because it is appreciated by the rest of the world that's still here. But from a technical point of view, olfaction and sensory deprivation, did you take your own positive smells chemically made into space to stimulate you at any particular time?
I think I heard the question. Sensory, was it about your sense of smell? Interestingly, it's what we're more aware of medically is your sense of taste seems dampened in zero gravity, whether that's the gravity effect or the sort of sterilized and scrubbed cabin atmosphere that you're operating in is not quite clear. But even astronauts who prefer very bland food on Earth really sort of crave either some salt or some hot sauce or something to heighten back up their sense of taste. I don't recall any particular odors within the spacecraft when I was there, but on the 4th shuttle flight, my job when they landed, it was just a 2-day test flight. They landed, we're out on the runway, and my job with another astronaut was we go aboard and we relieve the 2 people that have flown the mission. We take over so they can leave the spacecraft, go get their physicals and all that stuff. And so this was 2 people in the cabin for 3 days. And when you come into that cabin, it has its own distinctive smell. It's a little tiny bit like a locker room smell. Not a bad locker room smell, but a tiny bit like a locker room smell. That the crew is not aware of it at all because it evolved slowly with them as part of it. But if you hit it fresh from the outside, you would remark it. And I'm sure everyone who opened the hatch and came into my spacecraft on any of my flights had the same, oh, you guys have been in here a while.
Okay,
right up
final question down the front.
Did you face any challenges in your career for being a woman?
Did I face any challenges in my career for being a woman? Yes and no. I mean, I came along far enough down the road. There'd been, the way I like to put it is, there'd been other women before me move into engineering or the sciences, and kind of the door was ajar. We were not completely the first ever that anybody had seen. When we came to NASA, we were all rookies and young, but we walked in the door with the fanciest title the agency has. So I think if you walk in the door and you're weird, like you're female or your skin is dark and people haven't seen, no one's seen people like you be a cadet, you'll get a little bit of reaction because you're that different, and you'll get the typical, tease the cadet reactions. And almost any organization, there's a kind of teasing, sometimes bordering into hazing of new kids. But we walked in with the essentially senior most title you can have. So I think what I saw was, I sometimes could tell someone, one of the older men, was sort of a little bit looking askance. You know, I've never seen, you go into a conference room and sit at the table where decisions are made. There'd never been women sit at that table. If there were women in the room, they were taking notes for someone else, or popping in as a secretary and out, or something like that. So to come in and sit at the table where decisions were made would take some people aback. But if you were smart, we would go, the first time we did that, we'd go to the person who was chairing the meeting and introduce ourselves. Because the reason I would be sitting at the main table was because I was representing the flight crew. The people who are going to fly this next mission that you're talking about, I'm here as their representative to report back to them and help make sure good decisions are made. Well, no one argues with the flight crew. So if you had that senior person announced to the room, you know, that, let me introduce Kathy Sullivan, she's here representing the flight crew. It had been announced that you're there and you belong there. And so that raised the bar for anyone who wanted to maybe give you some grief about being at the table. So we got a grace period because of the title and the standing that we had. But in quick order, you're going to rightly be judged on your performance and your track record. So I think we got spared. We didn't get spared the skepticism on some people's part, but we got spared somehow. They might have thrown that skepticism at us more strongly if we did not have the title and position that we had. With the title and position, they'd kind of shut their mouth a bit and say, yeah, well, we'll see how this goes. But then you got to show your stuff, and I don't think it took very long for people to realize they looked weird when they came in, but they sure know how to do the job. Okay. The other part is you've got to own, you know, we knew we had earned that title. We knew we were not, you know, quota kind of hires. And so you have to own that yourself. And you have a position of responsibility. I'm representing the flight crew. I don't care that you don't think I should be. I am. And I'm going to do that job well. And so you have to be prepared to defend your standing and your position and the responsibility that you've been given. Great questions all. Thank you again very much for having me here today.